Hi everyone, welcome back. This is MLOps Zoomcamp session 4 about model deployment, and in this video we will talk about machine learning on streaming data. In this video we will use AWS Kinesis and AWS Lambda. AWS Kinesis is an event stream, so this is something you can send events to and read from them, similar to Kafka and other message brokers. And we will use Lambda as a consumer, so we will read data from Kinesis using Lambda. So it will be all based on AWS services. This video is optional. You don't need to watch it to complete your homework, but I think it will be useful anyways. So maybe you don't need it now immediately, but when you need, come back to this video, check it out. It will also be rather long, I think. And in this video, we will see what we need to do to actually create a stream, create Lambda function for consuming from this stream, and then put our model in the Lambda function. Before we start, let me quickly recap what we did so far. So in the previous videos, we saw how to deploy a model as a web service. We fetched the model from S3 location, from the artifact storage that MLflow created. And yeah, we have this a couple of functions for preparing features, for applying the model on these features, and we actually use the pipeline here. Pipeline that, let me show you. Pipeline that combined dictionary vectorizer and random forest regressor into one model, one pipeline. We stored this in MLflow. We downloaded this from S3 and we applied this to incoming requests. We want to do something similar, but in streams. And here, I must admit, the example we have predicting the duration of the ride is somewhat not ideal for this example for streaming, but we can imagine that we have two models, one that is deployed as a web service that is and gives an okay estimate, and the model we want to deploy now is better, so it can give a more accurate estimate when the ride already started. Even though it's actually even worse, you see the RMSE here is quite bad. We actually should have used XGBoost model here, but let's pretend it's a good model. It's a very good model. It's better than what we deployed previously, and we want to deploy it to put this to Lambda to react to a new event in the stream when the ride started. So we consume this event and we give a more accurate estimate to the user. So let's start. And some of the things I am going to show you here are based on this article. I have it open here. And in this article, they show how to do what we need to do here, except they don't really talk about machine learning. They just show how to use AWS Lambda with Amazon Kinesis. And yeah, so we already have prerequisites. Yeah, and here we start with creating a function. So I will go now to AWS and do Lambda. By the way, before we start, if this is the first time you hear about Lambda, maybe it's worth checking our ML Zoomcamp. We talked about Lambda as well, but we talked about using Lambda in context of deep learning models. So how can we use Lambda for that? But yeah, you can check it out. It's pretty detailed. We show in this section of ML Zoomcamp how to deploy a model, a TensorFlow model with Lambda, and then expose this as a web service. So it's pretty useful. I do recommend checking it out if you haven't. Yeah, it also talks about Lambda in more details, but I will quickly give you an introduction to Lambda. You can see that the main promise of Lambda is run code without thinking about servers. Here, this is the main idea, right? So you do not need to host your model anywhere. Like, you don't need to own the servers or create EC2 instances. You just write a piece of code and it is executed somewhere. And you don't need to care about where exactly it is executed. All you care about is it gets executed, and it does. So you don't need to worry about anything. Yeah, here we can create a function. Before doing this, because we are following this tutorial, like in this tutorial, actually they start with creating a role, execution role. So because we want to connect Lambda and Kinesis, we need to first create a role. So this role will describe what kind of permissions the Lambda will have. And in particular, it needs to be able to connect to Kinesis to read from Kinesis stream. So that's why we first need to create a role. So we go to IAM. This is like access management. And here we need to create a role. So I go to roles, Let me actually check if it's a role. Yeah, create a role. And here I select Lambda. Next we need to find a specific policy that we want to attach to this role. So policy is a set of permissions that are already defined, could be defined by us or by Amazon. In this case, we want to create a predefined role, and this is the role. So now I hit enter and I find the role. We can see what is inside it in this role. So this role, let me enlarge it. It kind of becomes ugly. Okay. So this role, what it can connect to Kinesis, so it can get records. We can see what kind of shards. Shards is like parts of the stream, so you can break down the stream into multiple partitions, shards, and we can see what are the partitions there, what are the shards. So this is what it does. Yeah, so basically this set of permissions allow us to read from the stream. This other set of permissions allows the function to produce logs, and we will be able to see the logs that this function creates. This is pretty useful. And then, yeah, the resource star, it means that it can do it to every Kinesis stream and every log group. Okay, so that's fine. You can just click next. And then the role name would be, let me write something like Kinesis. Maybe they have a name. Yeah, Lambda Kinesis role. Let's just go with this. Yeah, don't need to change anything here. Create role. Cool, we have the role. And now we need to create a function. So we'll create a function. The name of the function will be right duration prediction. First, I'll create a test function. We'll just use it for testing, and then we'll create another function which we'll call right duration prediction. So we want to use Python 3.9 and change the default execution role to use an existing one, and the existing one will be Lambda Kinesis role, the one we just created. I don't think we need to change anything else in advanced settings. Create function. Okay, we have created a function, and here we can already write some code here. So for example, here event, this is the event that we read from the stream, or can be anything. Like for example, if we connect the Lambda function to an HTTP endpoint, then this will be the request that comes to this endpoint. So it can be anything. So let us print. I even want to print, like typically this is a dictionary, so I want to print it as a JSON string. So do JSON dumps. So it will convert the dictionary, the event to JSON. And then let me just leave it like that. Yeah, I don't think I will change anything. So now I deploy the function. So because I changed it, I need to deploy it. And then I want to test it. Here I will create a new event. I'll call it test. And this is the content of the event. So I'll save it. And now I click test. And actually, yeah, this is the function. And this is the event that we sent to the function, right? Yeah, this is the response. Yeah. So, and we can put anything we want here. So for example, it can be a model. Let me take some of the things from here. For example, this one, right? So predict. For now, let us just have a simple model that predicts that everything takes 10 minutes. Quite a stupid model. And we need this thing, of course, as well for preparing features. And this event will be actually the write. So write event. Actually, in this event, we will have write, and we will also have write ID. So previously in the client-server architecture, when we send a request to a web service, when we get a response, we always know which write we sent to the service. So we know for which write we get the predictions. But in case of a stream, we send something to the stream, and then the consumer consumes from the stream, does something, and then writes the result to another stream. So we need to find a way to correlate the event we send to the stream with the result, right? That's why we need also to send some sort of ID to be able to find the predictions later. So then we can say that each event should have a write ID. So this is the ID we can use for relating two events, and it will be in the write ID field. we'll just invoke these prepare features. On the right, this will be features. And then we do prediction, right? Predictions or prediction. I'll do predict features. Yeah, let me comment this for now. And then we'll have right duration. Then it will be the prediction. And right ID will be the ID. So this will be our Lambda function. Let us quickly now first deploy and then test it. So I will change the test event, and I have an event here in the README. This one, we will use this one. Okay, save it, and I test it. Yeah, so the response is for this write that we sent, the duration will be 10 minutes. And of course, we just need to now to figure out how to put the model here. And this is what we will do for the rest of this video. But yeah, of course, we also need to connect this function to an event stream, to a Kinesis stream, which we will do right now. And I will, for now, comment this. And I will just put prediction 10. And I will uncomment this, because now we want to, when we connect this to Kinesis, we want to see in which format Kinesis sends us these events. And that will help us to figure out how to process these events. So I will save this. And yeah, now we need to connect this to Kinesis. So I click here at trigger. Even before that, actually, we need to create a Kinesis stream, right? So I go to Kinesis. And let me quickly check the tutorial. Right, so we created a function, then we tested. Yeah, we need to create a stream. So here they use AWS CLI. I want to show you how to do it with UI, but of course, feel free to repeat everything with the CLI. Yeah, they say we need to create a stream. Let me go here. We need to create a Kinesis data stream. And actually, I want to do it in Ireland. My function is in Ireland, so the stream should also be in Ireland. And the stream name could be, I don't know, write events, for example. And here I choose provisioned and only one shard. And depending on how much traffic, how many events we have, we need to select the amount of shards. It tells you how to actually do this. We will not have a very high throughput stream, like we will not have a lot of events, so we can just go with one shard. And yeah, please note that we need to pay for each shard per hour or something. Like, it's not a lot. We can check how much it is actually. So it's in provision mode. For example, Ireland, per hour it's 2 cents. I don't know if it's actually a part of free tier or not. Maybe it is, maybe it's not. Yeah, but it's not that expensive. And for your experiments, maybe you will not need more than 1 hour, so you will need to pay like 2 cents. Anyways, it costs money. Don't forget to delete it after you finished experimenting. And yeah, let me just create a data stream. So we created this. It might take some time, but typically it doesn't take 10 minutes, it takes less. But let me copy the name. And then now I will go to Lambda. And here we select as a trigger Kinesis. And we select these write events. We don't need to change anything here. Let us just add the consumer. Yeah, I don't know what that is. It shouldn't be the case because actually the Lambda should have the permissions to do this. So let me just try one more time. Maybe we actually forgot to, let me quickly check the this IAM role. Maybe we forgot to attach the policy to this role. So the role we have was was it Lambda Kinesis role? And permissions, yeah, we forgot to attach the permission. Yeah, sorry. And permission was, I forgot already. So I should have clicked something like attach. Yeah, attach policy. Yeah, policy was successfully attached. Okay, so let me try one more time. Cool, now it works. What we can do now, it will probably take a bit of time, like to attach Lambda to Kinesis. Let me refresh it. While it's creating, I think we can already start. Yeah, it works, it's enabled. So let me get the name of this thing, which now I will go to README. And in the README, I want to change it a little bit. So what I want to do now is to send a test event to the stream, and then we should see Lambda react to the test event and print the content of the event. So I will just copy this. So first of all, we create a parameter Kinesis stream input. So this is the stream with the input events to our consumer, to our Lambda. And then the stream name, yeah, we need to specify that, and partition key. So we always need to specify the key. The key, it should be, in our case, write ID. And then Kinesis uses the ID to understand to which partition, to which shard to put the event, the record. And then this is what we send. Hello, this is a test. So now let me execute this. Okay, now we see that it successfully executed this. It successfully put the event to the stream, and our Lambda now should read from this stream, should consume from this stream, and we should see this in logs. So I'll go to the Lambda now, monitor, and here we have logs. And then now I will click on view logs in CloudWatch. So our Lambda now can write logs to CloudWatch, and we should be able to see the logs here. And we click here, and yeah, actually it seems like we have a bunch of errors. So let me go back to Lambda and fix the error. Yeah, of course, write ID, it's 1, 2, 3. Yeah, deploy. But yeah, you see that it keeps retrying this. So there is an error and it keeps retrying this. So there is some retry mechanism. I hope it will stop now. But the interesting part for us is this one. So here we see how the event looks like. So this is the event that Lambda receives, because we have this print statement that actually prints this thing. So now let us copy, and I'll put it here. So what we see here is, yeah, so first of all, it's a list of records. So Kinesis fetches, Lambda fetches multiple events from Kinesis up to 100. This is something we configured when we did the connection. Consumes the events up to 100 at a time. And then, yeah, so there is the ID of the event, like a lot of meta information, where the event is coming from, which stream, because we can have multiple triggers in Lambda, so it can consume from multiple streams. So we know from which one it comes. And this is the actual event. Well, the actual event is actually here, right? So there is a bunch of stuff, but our event is here. This is not what we sent, right? So what we sent was hello, this is a test. So we need to actually decode this. And this is base 64 encoding. So we need to decode this to be able to see what we sent. And for that, I have a code snippet that we can use, this one. So I'll go to our Lambda right now. So I need to import, I think, import base 64, and then put it here. So actually, first of all, we need to have a for loop. We need to have a for loop because this is a bunch of records. So I'll do for loop for record in event records, and then in each record we need to access this Kinesis event, record Kinesis, and then we need to access this data, and I'll call it raw data or decoded data, encoded data. Now we need to decode it, put it here. Now it will be decoded data, and now we can print the decoded data. Okay, now let us test it. And what we can do, we don't need to keep sending the events to the stream. What we can do is we can just take this thing that we sent and put it here. So I will create a new event here. I'll create a test Kinesis. I'll put it here, save, and test. And we see that we print the record. Then our base 64 encoded data is here, but we decode it and we see that this is a test. But this is not what we actually want to send. We want to send an event about the write. And I have another code snippet here. This is our JSON, and this snippet sends the event about the write in JSON. So this is JSON. So now let us execute this. And let us go to Lambda and see what it does with this. We'll go to this write duration prediction test, and then each time we click deploy here, there is a new version of Lambda deployed, and then it creates a new log stream. So for us, we're interested in the latest one because it corresponds to the latest version of the Lambda. And we see that, yeah, this is the event we received. Let me copy it because it's more interesting than the test event that we sent previously. So I'll put it here. And we also see the encoded thing, right? So this is the JSON. We still haven't parsed it, but we see that we were able to decode it and to print it. So now let me go here again to the Lambda function. And we know that this thing is JSON. So we need to do JSON load s load string, and then it will be our event. Oh no, event is a bad name. Write event maybe? Write event. And then let us just print this, and let us take this thing here and change our test event. We are no longer interested in this test event, we're interested in the actual JSON. So I will save it, and now, okay, I need to deploy it, and then I need to click test. And we see that this is the write we get, so we successfully decoded it, and now we can apply it to basically do this thing, right? So I will uncomment this. And then since actually this is, now replace it with this one, write ID, we don't need this because we don't have a model, right? So we still have this, yeah, here this thing works, so yeah, we can keep this thing. But we don't have a model, so it will be always a constant prediction. And then we need to put predictions here. So it will be all the predictions because we have multiple records. We need to loop over all of them, and we need to put predictions. I will do something like this. So we will append the prediction, and then at the end we will return predictions with the predictions. So and if we send, because Lambda might consume 100 events, and then there will be prediction for each of these events. Let's test it. I will deploy it first, and then test, and then something is wrong. So key error, right? Let me check. Yeah, I think because it should be write event, not event. Now let us deploy it and test it one more time. Okay, now it works. So we have predictions here. This is our event. This is our write. All good. So I think I can probably comment this because we don't need this. I can comment this one as well. And yeah, this is the code. One more thing that here we output this. So we see the results here, right? But actually what we want to do here, instead of outputting the result to the user to see the response, because remember, we do not have this client server architecture, so we don't show the response to the user, to the client of to our client. We actually want to send the response to another stream, right? So in this case, we want to, here, let me just put this to create a variable here, prediction event, and this is what we will send to a different stream. We will put to another stream. Then I'll save this. I will go now to Kinesis again, and I will create a stream with write predictions. It will be again provisioned, one shard, create a data stream. Then another thing actually here may be what we are interested in, because there could be multiple things that put to these right predictions. So maybe we need to know like which model created this. So we'll have right duration prediction model, then maybe version of this model. For now, let us put 1, 2, 3, and then prediction, and this will be the prediction for this particular model. Because we can have multiple consumers, so we need to know from which consumer this event is coming from. So we need to add a lot of extra information in case of streaming as opposed to web service. Because in case of web service, we know from which model it's coming from, which prediction it is. We don't know the version, that's why we include the version. But yeah, in case of streaming, we need to have all this information because the consumer has no idea which thing produced this event. And now we just need to find a way how to send this thing to another stream. So for that, we will use Boto3, which is a client for AWS services. And yeah, I have a code snippet here somewhere. Do I? No, I think I forgot to prepare this, but yeah, let me improvise. So client, so we'll need to create a I'll call it Kinesis client. So it's Boto3 client Kinesis, right? And then this gives us a client for interacting with Kinesis streams, and then in this client there are some functions for interacting with the Kinesis stream. Let me quickly look it up. Boto3 Kinesis send message. So this is the information about the client. Yeah, this is exactly how we invoke it. And what we need is put a record, or even put records. We want to put multiple records, right? This is the example. So I will copy this and put it here. And so this is Kinesis client. Let me remove this thing. We have Kinesis client, put records, and records will be these predictions, or called prediction events, and this will be the records. Wait, we need to put a lot of information here. Yeah, maybe let's, instead of using put records, we will use put record singular. This should be this one. Yeah, actually using put records is cheaper because you pay for each API call, and let's say if you need to process 100 events, then invoking put records is cheaper. It adds a little bit more overhead to the code, which I don't want to have right now in this example. But yeah, definitely if you need to process a lot of events, use put records instead of put records. But I want to make it a bit simpler, so I'll just do Kinesis client put record, and then there should be an example how to use it. I'll just copy it. Yeah, so stream name, this is something we need to configure. I'll just do stream name. We can make it configurable using environmental variables. Predictions stream name, and we'll use this os get env, and yeah, we will get this from the configuration, but the default value will be this one. So right now I will not send this environmental variable, so it will use the default one, which is this one, right predictions, and then this will be the stream name. Then data is this one, so I'll do JSON dumps and then prediction event. And partition key should be a string, so in our case it's right duration, but it should be string, so we wrap it in a string. And these two are optional, so let's not add them. And we remove this one. Okay, what we did is now for each prediction event, we will put a record to another stream. to another Kinesis stream with the results, right? And at the end, we will also output this, but this is more for us, for testing, so we know that this thing actually works. But the main output of this thing will be this Kinesis client. We should test it. I think if I just deploy it and now click test, it will not work. And the reason for that is that the role we have here, the role that we created here, does not have permissions to write to a stream. But let us see the error. So I'll click test, and yeah, this is the error: access denied exception when calling the put record operation. So we need to allow put record on this role. So this is actually the resource we need. So I'll copy this. Now I will go to IAM because we need to add the permission, and I will add permission attach policy. So we will create a new policy, which will be, I'll call Lambda Kinesis, write predictions. Create policy. Yeah, this is actually, like, this is the search field, right? And this is something I needed. The name is something I needed at the end. I'll just put it here. So service is Kinesis. An action will be, we need these two, put record and put records. I don't know if we need anything else. These two should be sufficient for this one. Then specify the stream ARN. So there is a specific resource we want to write to. And this is, where it is? Yeah, this is the ARN. The resource, what happened? Okay, this is the resource, the specific resource we want to use. And I want this name. So we don't need to add any text. And now we add the name, and then allows Lambda to write to the right prediction stream. Okay, create policy, and now we'll use this policy we will attach this policy to the role that Lambda uses. We can attach multiple policies to each role. Okay, now it should, I need to refresh it, and now I need to click attach policy. Policy was successfully attached. Now we have two policies. This is the policy we just created. We allow this role to invoke put record and put records to this particular resource. So this is a very restricted role. It can only do these two things for this particular resource. And usually you want the roles to be as restrictive as possible. Only allow things that you need, which is this one maybe is not a good example. Maybe we should make it more restrictive, but it's okay for now. Okay, I don't think we need to click here anything else. So now let us execute it one more time. And now prediction events is undefined. What happened? Yeah, we need to update this thing. Deploy, test. Hey, works. So we were able to write now to another stream. Now we need to figure out how to actually read from this stream and check that our function worked. Yeah, I have a code snippet for that as well, because this code is a little bit involved. So this is how it looks like. So we will use the AWS CLI for reading from a stream. This stream only has one shard, so that's why we just hard code the shard ID. In case you have multiple shards, you need to know from which to read. Here we will not worry about that. The stream we have with predictions is write predictions, which is the same as I have here. Then this is the shard, this is the stream name. Stream horizon means that everything that is there on the stream should be there, like we want to read that. And this shard iterator gives us an ID of an iterator. An iterator is something we can use then later to retrieve the records from the stream. It's a little bit complex. Maybe don't worry about that too much if you don't understand. Lambda hides all this complexity, so we don't need to worry about all that. It just gives us a way to read it, and we don't need to worry how exactly. But now we want to read this without Lambda. We want to read the predictions without Lambda, and for that we need to worry a little bit with all this stuff. So, but we don't need to do it often. We just need to do it once. And let me do that. So I execute that. And now we can see what this shard iterator is. Yeah, so this is just an ID of an iterator that we can use for querying the stream. And this is how we do this. So we do Kinesis get records, and then we provide this shard iterator, and it gives us records. So now I execute that. And now if I print this result, this is how it looks like. I have a tool, or I should have a tool called JQ that formats it. So you can install it if you don't have it. It's apt get install JQ. If you use Windows or Mac, check it out how to install it. It's something similar to that. But yeah, it gives us a way to present JSON in a nice way. Yeah, we can also access a specific record. So for example, this piece of code that we have will access this first record. So let me put it here. So it will access this thing from here. And I think they are identical. Maybe we just invoke the function 2 times. Well, that's why we have 2 records here. Yeah, now the whole thing will take the record from here, the data, and use base64 decoding to show. Oh, sorry, didn't copy it. To show what is actually there. And maybe we can again combine it with JQ to see nicely. And this is the answer we have. The prediction of the model. We see which model was it, which version of this model, and the actual prediction. We are almost there. The only missing thing is the actual model, right? The important part. And now let us do that. Let us add the model to this Lambda. And for that, we will use Docker. We will put our Lambda code in Docker. But first, I will create this Lambda. What's the name? So first, I want to copy the Lambda function that we created to Visual Studio Code. So it's lambda function.py, and I just get all this code and I put it here. Now we need to figure out how to add model here, right? So instead of this predict, we want to have the actual model. And what we can do is we can just take this code here. We'll do that. I'll take this code here and I will put this to the Lambda function. And if you remember what this code is doing is here we import MLflow, right? And with MLflow, we load the model using this run ID, and now we can apply the model. And this model is actually a pipeline, so we don't need to worry about dictionary vectorizer and whatnot. And then we can just use this model on these features and get the prediction, right? So it will be something like model predict features. I don't even know why we need to put this in a function. Well, let us keep it this way. Yeah, cool. Let us quickly test it. So I'll create a file test, and I will take, where is the event? This will be the event. So event, and yeah, we will import lambda handler, it's a lambda function actually, and then invoke that lambda handler event. And then there are actually 2 parameters, if you remember. There's an event and context. We don't care about context, we just care about the event. So context is none, event is this one. You know what, actually this is not the event, because the event is this thing, right? So let me copy this, it's more complex. And the result is here, and we can just print result. Let me try to execute this. So I'll need to go to 04 deployment, streaming. So I'm in this folder, and then I just do Python test. Yeah, now the problem now is we didn't configure the function. So there are a couple of things we need to do, like this get run and then prediction stream. So I'll add this at the end of, well, maybe not here, not at the end. Yeah, here. So we will need to configure this. Prediction stream name will be this one, right? Run ID. Let me quickly check MLflow. should be the latest one. So this is the run ID. Yeah, maybe now for testing, like I don't really want to send events right now, so I will comment this for now. Later we will need to remember to uncomment this. Maybe I'll do like dry run was getenv dry run, and then it will be by default, or maybe test run. So by default it's false. If it's equals to true, then it's a test run, and then what we will have here, if not test run, then do this. So we will only put the records if it's not a test run. And by default it's not a test run, so we can add test run true, and then we do python test.py. Test. Yeah, let me check this. Something is off. Yeah, of course I need to add export. Okay, this is actually expected. Good thing it almost works. Yeah, so this object of type something and the array is not JSON serializable. The problem is that this thing, or is the lambda function? So here we have a prediction, and we actually need to return prediction 0, right? And we need to put it in a float. Lambda cannot convert to JSON a float from NumPy array, so we need to convert it to a Python float, and then Lambda will be able, or it's actually the default JSON library, it will be able to convert these predictions to JSON. Let us test one more time. Okay, so good, so far so good. We now need to package this into a virtual environment, then create a Docker image. So I'll just do pip-n install. So we need boto3, mlflow, scikit-learn. What else? I don't think we need anything else. So we use boto3 here, we use scikit-learn here, and we use mlflow here. I don't think we need anything else here. And then version of Python, in our case, will be 3.9. And while it's installing this, while it's creating this, I will go ahead and create a Docker file. And Docker file, now we need to use a specific version of Python. It's not the same version as we used previously in the web service. We need to use a Docker image from AWS, and I keep forgetting the name, so I need to usually to Google. It's AWS ECR public registry, and then they have some links here. This gallery ECR AWS, and then here I need to find Lambda Python. Yeah, this one, Lambda Python, and we'll go to image text, and yeah, this one. 3.9, this is what we need. I just copy it. So from this one, it should already have pip, but as previously, let us do first pip install upgrade pip, and then we do pip install pip-env. Let me just copy this from the previous Docker file. Yeah, I'll just copy, not everything, but some stuff. So we need this. We do not need to set workdir because there is already a specific working directory here. We don't want to unset it. So we want to copy our stuff there. And we want to use pip-env to install there. And then we want to copy our Lambda function also to that directory. And the last thing we need to do is we need to, instead of providing entry point, we need to tell Lambda where to find the Lambda function. I keep forgetting the syntax, so let me quickly look it up. But since we had this ML Zoomcamp, we used Lambda there. I'll quickly go there and check how the Docker file looks like. Yeah, this one. So we just do cmd Lambda function, Lambda handler. So it goes to, it's very similar to GUnicorn. So it goes to this Lambda function and looks for a function with this name, Lambda handler. And I think that's all we need. And now hopefully the README contains what I need. So I need to first build this. Am I in the right directory? Yes. Yeah, now we are building everything. I need to change this thing, right? Because we added a few things here for configuration. So let me add this to Docker as well. So I need to put this here. Then the next one is run AD. And then the next one is test run true. I actually don't know if now from Docker we will be able to pull the version, because yeah, maybe it doesn't have the permissions to do that. We'll see now. Yeah, let me run it. Okay, we now actually need to send a request to check if it's working or not. And for that, I will create another test file. I'll call it test web or test docker maybe. But the reason I wanted to call it test web is this Docker container actually exposes an address, and we'll use requests like previously. And this will be our event. And then we need to have URL. URL is a complex thing. I don't remember. I'll need to, I hope this one I do have in the README. Yeah, this is the URL for testing. You see it's quite long. And then we will do the response. It's requests post. This is the URL and this is the data that we sent. And we just print the response. Something like this. Let me test it. So I'll go here and do a test on Docker. Yeah, I need to configure this. So it says, you see that's erased no region error. So it's actually complaining that we didn't specify the region. Usually, like we can specify region here in the client, like region, for example, EU West 1. And if we don't specify, then the default region is used. For Lambda, we do not need to use this because Lambda just uses the region where it is deployed. Yeah, let us quickly try doing this, or maybe instead of hard coding it here, we can use an environmental variable. Like this link I found just going to Google and doing our AWS env variables, and this is the first link. And here we can find region, it's AWS default region. We can now add this. Oops. I think I will need to stop it. I got disconnected from the remote computer, so I need to stop it. And then I'll go again to MLOps Zoomcamp 04 streaming. And then I will start again. And let me just take this thing that I wrote and add this variable. This default region, and this will be EU West 1. And just to note that like this thing is working right now on a remote instance with an instance profile. Instance profile is a way of giving permissions to your EC2 instance without having to create keys like this access key, access secret. So that's why maybe I only need to specify the region, but let me check it. So first I'll do docker build, then now I'll do docker run. Okay, it's running. This one, yeah, it's also connection reset. So I'll do Zoomcamp for streaming and do Python web. Oh, what's the name? Python test docker. Okay, I don't know if it will work now or not. Okay, it's working, but actually for you to make it work, you might need to also add another keys. So if you're doing this locally or you don't have your instance profile configured, and if you have a key, you will also need to specify these things here. So you will need to say what is your key here, and what is your secret. Usually you already have them in your environment variable, so you can just do it like that and something like that, right? And then this way you can pass your credentials to your Docker. I'll save it, and yeah, we see that it works. Although there is an issue, right? We see that trying to unpickle estimator on a forest regressor from version this when using version that. I think the problem that we did not specify version of scikit-learn here. So let us fix this problem. I think it should be equals. Let me see how we did it for web. Yeah, it's equals. I think we should rebuild our virtual environment to make sure it doesn't happen. So let me stop it, and I will do pip-env --rm. So then it will remove the virtual env. Then I will also remove pip file lock, and now I will do pip-env install. It should use the Python I need, so because we specify the version here, it should hopefully find the Python of correct version and just use it. Let's see if it works. Yeah, it's good. So now we will need to rebuild the virtual environment. Then we will rebuild the image. Yeah, then we will test it one more time. Now let's rebuild. Okay, and while it's doing, I will have another copy of this command. So because now I don't need to specify this access and secret key, and I'll just hard code EU West 1. Okay, now let's run it, and I will execute tests. Okay, it still works. That's good, and we don't see a lot of warnings. There is a warning from MLflow, but it's about yeah, there are a few other things like, okay, for example, we should also pin the version of CloudPickle to 2.0.0. CloudPickle is like pickle. To be honest, I don't know what is the difference between CloudPickle and pickle. I know that CloudPickle is an external library. It's also good if you use the exact version of CloudPickle, because if you used CloudPickle 2.0.0 to pickle the file, but you use 2.1.0 to unpickle it, then yeah, might not work. Anyways, I will not do it now. I don't want to redo it. Yeah, it works. Now I will stop it. And next thing we need to do is we want to publish it to ECR. ECR is a Docker registry in AWS. So if we go to here, ECR. So this is this Elastic Container Registry. So this is the place where Docker images work. So we can just create one. So I will use the CLI tool here for this one, because it will output some information that is quite useful. We probably will have it here as well. I just want to use the CLI for this one. Yeah, let's call it duration model. And we are interested in this URI. This is the repository URI. And I want to put it here, because what we want to do now is we want to push to this URI. Yeah, and we want to push it to this location, this repository, and we want to tag this with version v2 or v1. I think this is also what we use here. And yeah, the local image is this one, v1, right? So the way we push to Docker image is we take our local image and we tag the remote image with local image. So we tell Docker that these two are the same thing. And when we say push, and then this long URI, it knows that it needs to push the local image. Before we can push, I actually need to authenticate with Docker with ECR using this command. So I execute this, and then I execute this as well. Okay, it should be pretty fast because I'm doing it from a remote instance. Now, from your local machine, it can take some time because it needs to push a lot of data. Yeah, even for a remote machine, it takes a bit of time. I'm wondering why it's so large. like 600 megs. It's quite large. Anyways, we finished this, and remote image. Yes, this is what we will use for our Lambda. So I'll copy this. Now I will go to Lambda, and actually we will need to create a new one. So this one we used there are multiple ways of creating a function. So let me just, oops, I think I just closed my camera. There are multiple ways of doing this. So you can author from scratch, or you can use a container image, right? So previously we used author from scratch. Now I want to use container image. And the name, let me check what was the name previously. So it was right duration prediction test. And for this one, let me just, oh, where's this? I'll use right duration prediction without test. And container image URI, this is what we just copied. Permissions, we need to use a different permission. This one, Lambda Kinesis role, create function. And then we need to configure our function. So we need to go to environmental variables and edit this. And we need to add a few environmental variables. Remember the variables we had were prediction stream name. This right predictions. And run ID. Okay, so this is what we need. We don't need to specify a test run. If we don't specify it, it will not be a test run. Save. Then we add trigger, Kinesis, and then this is our write events. We edit. Now it will take some time to create the connection. Okay, it seems to work. We can just now send a test event and see what happens. I think before that we need to remove this function, because it also has this one, because it also integrates with Kinesis, so we don't want two lambdas to process it. So I will remove this, the test one. Okay, now it should be only one lambda function reading from Kinesis, and I will now send this thing. So maybe let me change this to 156 so we can test that it actually works. So let me send this. Yeah, I think it doesn't work because I need this stream thing. Okay, now it should work. And we can go to our Lambda, to logs, go to our monitor. We go to logs and we click on view logs in CloudWatch, and we should see this in logs. That doesn't look good. Yeah, the reason for that is we need to give our Lambda function permissions to access S3. So let's do that. For that, we need to go to our IAM, so to our role, and let's add a new permission. So I will attach a new policy. So this policy will allow us to talk to S3, to the S3 bucket, and we will have read permissions and list permissions. There are so many permissions, I don't think we need most of them. But yeah, I don't want to spend, well, mostly we need just get object. Yeah, maybe I'll just do that. The rest, I don't think we need. Yeah, we don't need that. I don't think, maybe MLflow uses something apart from get object, maybe get object version, I don't know. And then for list, I think, yeah, that's also quite a lot. Maybe I'll just give all read and list permissions. I will not give it write permissions. And we will also need to specify the resource. How do you actually do this? Bucket, right? So the bucket would be, let us just go to S3. This is a bucket. So this is the name. And I'll put it here. And then we also need objects. Like I will bucket name and then object will be star. So it applies this to all the objects. And I want to see JSON. So it will look very ugly. So I usually, when I do this for S3, so I do get star and list star, and I remove the rest. So it will basically give all the get permissions and all the list permissions. And I don't know what this is. I will just remove that. So basically this is the permission. So we allow get and list for the bucket and for all the objects in the bucket. So let's go next. And I will call it read permission MLflow models. Okay, read and list permissions for. Okay, now create policy. And yeah, we need to have the name because we will now use it here. I need to refresh it, edit, and we can look at the policy. So this is the policy get and list. Attach the policy. And now let us test it one more time. This time I will actually not send it through Kinesis. I just want to test it through an event. So I have it here. So I'll save it. Test. Actually, it might be a good idea to give more. Yeah, exactly. Give more time because it needs to initialize everything, then load the model. So we go to configuration, general configuration, edit, and let us give it 256 megs of RAM and then perhaps 15 seconds. Usually the first invocation takes time, but then the consequent invocations are faster. And then test. How do I test it one more time? I think I need to wait till it updates. Okay, now let me test it one more time. It takes a bit of time. I'm wondering it's actually working. Okay, yeah, that was fast. I don't know what happened with the first invocations. Maybe just let me try to give it even more time. Maybe before, because the first time just takes some time, and then the consequent runs are much faster. Okay, test. So this might take some time. Okay, that was actually less than 15 seconds. And yeah, so you see that yeah, I think it needs more memory probably. But now if we test one more time, yeah, you see it's very fast. Now let us give more memory. Like, I don't know, 500 maybe. Also keep in mind that the more memory we give, the more expensive the invocation is. You can find out the pricing. If you give 2 times more memory, it will become 2 times more expensive. It's still pretty cheap, like a cent for 1,000 requests or something like this. Okay, let us test it one more time. Yeah, looks good. Yeah, it was using just a little bit more memory. Anyways, that looks good. So let us test it. I will send this command. I need, yeah, this Kinesis stream and this thing. It worked. Now let's check the logs. So now we go to the logs, monitor, view in CloudWatch. And we need to go with the latest ones. Yeah, we don't see any errors here. I should have added a bit of logging here, perhaps, but what we can do now, do this, right, like last time. So this way we just consume from the stream with results. And if I do echo results, JQ. We see that there are a lot of records. We, I think, are interested in this one, right? So I can do, just take this echo and then do base 64 decode. And this is actually this one that we sent right now with 156. You see it here. And maybe let me add JQ here so it looks better. Okay, I think that's all. That was a very long video. I hope it was still useful. So this is how you can deploy a machine learning model as a Lambda and let it consume from a stream of events. So yeah, we did quite a lot of things here. So we explored how Lambda works, how to connect Lambda to a Kinesis stream. Then we also saw how to put the model in the Lambda code, then how to package everything in Docker, and then finally how to deploy this. It took more time than I anticipated. It should have been probably like 4 different videos, but again, this is optional. Hopefully we will have timecodes for that, and yeah, you can just watch it when you need it. So now we covered both online ways of deploying web service and streaming, and we just have one left, which is batch prediction. So in the next video, we'll talk about batch predictions and we'll see how to use Prefect for that. So see you soon.